Hi everybody, this lesson is about compounds called hydrates. Hydrates are just compounds which include water molecules in their crystal structures. This is a picture of copper 2 sulfate, and you can see all the water molecules embedded in this ionic compound. The number of water molecules that attach to a particular ionic compound really vary depending on whatever the hydrate is. Anhydrous salts is another good word to know, and anhydrous salt just means a salt without any water in it. It's just a dry salt. I'd like you to know how to name hydrates. It's pretty easy because we already know how to name ionic compounds, and hydrates are ionic compounds, they just contain water. To name the water part of the compound, we're going to use some prefixes to identify the number of water molecules in the hydrate. These are the prefixes. These are also found in the back of your periodic table. So now we're going to look at an example. Here's the example right here. To start, we're going to just name this ionic compound as we've been doing in the past. In this case, iron has more than one oxidation state, so we're going to need to include a Roman numeral in this name. So we're going to write down the name of this ionic compound. We would name this iron, and the Roman numeral is going to be 3, because the charge on iron here must be a positive 3, and sulfate. So we have just successfully named this part of the hydrate. Once you've figured out the ionic compound, you're just going to use the appropriate prefix to indicate the number of water molecules. In this case, there's 6 water molecules, so we're going to use the prefix hexa. The water molecules are named as a hydrate. Again, there's 6 water molecules in this case, so the water molecules are named as hexahydrate, 6 hydrates. So if we put this all together, here's what the name is. Iron, Roman numeral 3, sulfate, hexahydrate. Hexahydrate. Here's one for you to try. Just pause this a minute and see if you can name this compound right here. Hopefully you had some success. The answer is nickel 2-phosphate, nonahydrate, nona meaning 9. Practice the following, naming the following compounds down below. This one here and this one here. Just pause this. I'll be back with an answer in a second. Okay, check your answers. First one should be iron 3 bromide hexahydrate. Hexa meaning 6 for the 6 water molecules. And the next one is sodium sulfate decahydrate because there's 10 water molecules in that formula. Now we're just going to write the formulas for these hydrates. Remember, the hydrates have 2 parts. There's the ionic compound and then there's the water molecules, or the hydrate part. So the first thing we're going to do is figure out the name of the ionic compound first and then use the given prefix to tell you how many water molecules there are. Here's an example. Iron 3-phosphate octahydrate. So the first thing we're going to do is figure out the formula for the ionic compound, which is, in this case, is iron 3-phosphate. To do that, we're going to know that the charge on iron is +3, the charge on phosphate is -3, so the formula is just, FePO4. Now we're going to look at the prefix, which is octa, and figure out how many water molecules we have. We've got 8. We're going to put it all together. Now remember to put a dot between the ionic compound and the water molecule. So the final formula is going to be FePO4, and we put a dot, 8H2O. Try the next 2 and pause this, and I'll have the answer up in just a second. I hope you had success. Copper 2 sulfate trihydrate. Did you remember to put the dot in and then the 3 for trihydrate? Next one is aluminum nitrate, and put the dot in. You've got 9 waters there. Next thing I'm going to do is show you how to determine the percent composition of a hydrate. The percent composition of a hydrate is very similar to what we did with percent composition before. The percentage of water in a compound can be calculated from its formula just as we calculated percent composition of an element in a compound. This is the formula right here that you're going to use to determine the percentage of water in a hydrate. This is also on the back of your periodic table. Here's a practice problem. Suppose we're asked to find the percentage of water in CaCl2.6H2O. First thing we're going to do is figure out the molar mass of calcium chloride. So if you add up the molar mass of calcium and 2 chlorines from the periodic table, you're going to get a molar mass of 110.98 grams. Then we're going to determine the molar mass of 6 waters. Well, a single water molecule 1 oxygen and 2 hydrogens weighs 18.02 grams. That's its molar mass. So I have to take this value and multiply it by 6, and that gives me 108.12 grams. Add the two together to get the mass of the hydrate. That sums to 219.10 grams. So to figure out the percentage of water in that hydrate, I just take the mass of the water, 108.12 grams, and divide it by the mass of the whole hydrate, 219.10 grams, multiply by 100, and that gives you a percentage of 49.35%. It's your turn to practice. See if you can figure out the percentage of water in barium hydroxide octahydrate. Just pause this, and I'll have the answer up in a second. Okay, you can check your work. Here I put the molar mass of the barium hydroxide, which is 171.35 grams. I added together the mass of 8 waters, which gave me 144.16 grams. So the mass of the whole hydrate is 315.51. Then I just took the mass of the water, put it over the mass of the hydrate, multiplied by 100, and this gives you your final answer of 45.69. The last thing I want to go over with you is how to determine the empirical formula of a hydrate. We're just going to follow the same series of steps that we did when we determined the empirical formula of an ionic compound from its percent composition. Remember that airplane activity we did? Here, we're going to treat water as a single unit, H2O. I'll give you an example. Washing soda is a hydrate of sodium carbonate. Its formula is Na2CO3 dot something H2O. A 2.714 gram sample of washing soda is heated until a constant mass of 1.006 grams of sodium carbonate is reached. What's the formula of the hydrate? So basically what we did here is took this hydrate, we heated it, the water evaporated, so its mass got smaller, and what's left is the anhydrous salt. So the first thing we do is determine the mass of the water and the dry salt separately. So to get the mass of the dry Na2CO3, we just write down what we're given in the problem, 1.006 grams. That's from here. To get the mass of the water, we're just going to take the difference between the hydrate and the actual dry salt. So I'm going to take 2.714 grams, I'm going to subtract 1.006 grams, and that gives me a mass of 1.708 grams, and that is of my water. The next thing you do is you change the grams to moles. So I'm going to take that 1.006 grams of Na2CO3. To change it to moles, I write 1 mole over the molar mass of sodium carbonate, which is 105.99 grams. Again, I got that off the periodic table of Na2CO3. And that gives me a mole value of 0.09. Whoops, that's not right. 0.009491. Do the same thing with the water. I've got 1.708 grams of water. I'm going to multiply that by 1 mole over the molar mass of water, which is 18.02 grams of water. When I calculate that out, I get 0.09478 moles of water. The next thing we're going to do is determine the smallest whole number ratio by dividing the smaller number of moles and rounding to the nearest whole number. So here I'm going to divide both of these by 1.009491. So I'll take 0.009491, divide it by itself, and of course that gives me 1, and when I take the water moles, 0.09478, and divide it by the smaller of the two numbers, 0.009491, I get 10. In this case, unlike the other empirical formula problems that we did, this value is always going to come out to be a whole number or really close to it. So we're never going to have to do that multiply by a small number thing. So in this case, the formula of our hydrate is just Na2CO3 dot 10 H2O, because we just figured out we have 10 water molecules per every one ionic compound. Your job now is to try the Hydrates worksheet, which is on the next 2 pages, using these as examples. You're going to be, again, writing formulas for hydrates, naming hydrates, determining their percent composition, and looking at empirical formulas of hydrates. Good luck. See me in class if you have questions.
Made with Doodlecast Pro.